What does dq stand for? Difference quotient. What did we find with limit h approaches 0 dq? The slope of a tangent line. What is a tangent line? A tangent line is a line that touches a curve at exactly it drew that line. Of course it is going to touch more than 2 points, so I'm just going to stop right there. Well, on any interval, a line that touches 2 points on a curve, so it touches there and touches there, and that is what we call a secant line. But on the other hand, if you want to find a line that touches a curve at exactly 1 point, then that line is what we call a tangent line. So it's slightly increasing at that point. It's not fully increasing. If I draw a line here, it is going to look like that. Do you agree? For it to touch the curve at exactly 1 point. Yes? What else did the limit h approaches 0 of the difference quotient give us? Slope of a tangent line. Huh? Equation?
Yeah.
Well, yeah, we could find the equation of the tangent line, but it gave a quantity. It starts with the lesser d derivative, so it gives the derivative. And what is the derivative in layman's terms? Apple is very invested in this. That's my hint. Steve Jobs likes this other term. No one? What does that stand for? Instantaneous rate of change. Okay. At that point, what is the instantaneous rate of change? Exactly at that point. Connect all these together. Instantaneous rate of change is the same as the slope of a tangent line. It is the same as the derivative. So I'm asking you, well, what is the instantaneous rate of change at exactly that point? So you can answer that question by going back and looking at that. What is the slope of the tangent line at that point? I know it's 8 a.m. in the morning. Do you guys plan to get a full-time job? Yes? Imagine you go to your job and sit like this at 8 a.m. in the morning. Do you think you could be productive? No? Yes? No. So, instantaneous rate of change is the same as the slope of a tangent line. What is the slope of that tangent line, which is touching the curve at exactly 1 point? 0. Why is it 0? Was that you who answered? The line is flat. It is a horizontal line, so the derivative is 0. The slope of the tangent line is 0. Here, do you know the value of the slope? We haven't done any calculations. We do not know. But we do know the sign of the slope. What is the sign of that slope? Is it positive or negative? It's positive. So right about there, it's slowly increasing. Now, if I draw a line touching right there at 1 point, well, that's not great. I'll use one right here. Negative. If a line has a negative slope, then it is a decreasing line. Yes? If a line has a positive slope, it is an increasing line. So by looking at the derivative, I can say if a function is increasing or decreasing. So right here, it's decreasing. Agreed? The curve is decreasing also. At that point exactly, the curve sort of made a turn, so it's flat, neither increasing nor decreasing, it's just making a turn. If I draw a line somewhere over here, would it have a positive slope or negative slope? Positive. If I drew one over there, would it have positive or negative? Negative, and so on. Does that make sense? Okay. Do not forget, when we find the limit h approaches 0 of the difference quotient, we are finding the slope of the tangent line, which is the same as the derivative at that point. The derivative at a point is nothing but the instantaneous rate of change at that point. Good? Do not forget this. Great. Now we did a bunch of examples on difference quotients, bunch in the video I posted, bunch in the homework. If you started the homework, did we start the homework? Did we? How many of you started the homework?
I did like 1.5.
It does have no limits.
Yeah.
Yeah. Okay. Get started as soon as possible. I think the first exam is on the 25th. It's like 2 weeks from today, maybe, or something like that. I did mention this in one of the videos, so I'll just repeat before we get into finding derivatives. The derivative of a function f of x is denoted by f prime of x, or you could call it as y prime, or it is dy over dx. Why is it y? Because we always call a function f of x as y. But the key thing to note is if the dependent and independent variables change, So if I have the dependent variable as r and the independent variable as s, r is a function of s, and that function is g. So how would the notation change? Here it would be g prime of s equals r prime. You have dr divided by ds. So the key to note here is to take the derivative of the dependent variable with respect to the independent variable. Good? So over here, this is the derivative of the dependent variable y with respect to x, which is the independent variable. Can someone put this in words? dr divided by ds. Use the same language. How would you explain it to me? Go ahead.
The R is the dependent variable and S is independent variable.
I can't hear you.
The R is the dependent variable.
Yes.
And then S is the independent variable.
That is correct. So in words, what would this mean? I wrote this in words. dy over dx means this. So what would dr over ds mean?
The derivative of dependent variable with respect to the independent variable.
So this is the derivative of Good. Do we see the connection? Yes? Okay. So to find the derivative of the function, first we have to find the difference quotient, then take the limit h approaches 0, and then simplify it, do a whole bunch of work, whole bunch of algebra to get the answer. But do we really have to do that each and every time? If you did an example, well, we did one in class, it took a while for us to find the difference quotient, then taking the limit h approaches 0. But it is not effective, so people sat around and found derivatives of certain functions. So all you have to do is know these certain functions and you should be able to find the derivative easily. Even before I give you the answer, can someone tell me what the answer should be? Think. Derivative, it means the instantaneous rate of change at a single point. And I'd like to find the rate of change of a constant with respect to the variable x. Would it just be C? Okay, Moses says C. Zero. What's your name? I forgot. Jaden. Jaden says 0. And now we have carbon monoxide. Why did you say constant, Moses?
Oh. Now that I think about it, it's a constant, the slope is going to be 0. So.
Exactly. So y equals c is a horizontal line. And we know a horizontal line has slope 0 at every single point. So the answer is 0. In layman terms, would a constant change with respect to x? What is the fundamental definition of constant? Something that does not change. So c is not going to change with respect to x. So we want to find the derivative of x raised n with respect to x. So the derivative is possible because we're doing it with respect to x. And n could be any real number. It could be 5, it could be 10, it could be 1/2, it could be -1/2, it could be 0.5, 0.3. N could be anything. It could even be 0, in which case the answer is just 0. What does the rule state? If you see something like this, the n is going to move to the front, x, and the power will decrease by 1. That is a rule. Now, could I prove it to you? Yes, but I don't think we need that in this class. But as I said, people did some work to save the time when it comes to practice. You don't have to use the difference quotient each and every time to find the derivative. Good? Okay. I don't want to write it this way. It looks complicated, but actually it's not. I'll write an example on the side here. You can put that plus or minus, it really doesn't matter. Suppose we have a, which is a constant, multiplied by a function, plus or minus another constant b, multiplied by a function, and we want to take the derivative of the entire expression. As long as we have plus or minus, it is the key part, as long as we have plus or minus, we can distribute this derivative and write it as that. Just like distributing a number 3 into, an expression, or a number 2 into an expression. So as long as you have plus or minus, I can do this easily. And also, if you have a constant multiplied to a function, the derivative is going to affect the function, but not the constant. So you can pull the constant out. So the answer would simply be a multiplied by f prime of x plus b multiplied by g prime of x. In other words, a multiplied by the derivative of f with respect to x, b multiplied by the derivative of g with respect to x. Good? In other words, we are finding y prime dy over dx, f prime of x, one and the same. What is the answer?
Be 0.
Would it, Moses?
Yeah, because
2 is a constant, so if I use rule number A that I just wrote, the derivative of a constant is 0. I'm saving this for a reason. Want to find the derivative of y equals x cubed. Obviously, that is not a constant. Do we agree? Now, so we have x raised something, and one of the rules states if we have x raised n, we can do something. What is n in this problem? 3. So n is 3, and what does the rule state? You pull what to the front? X. Look at the rule.
3x.
3 moves to the front, and you have x, and what happens to the power? -1. So you have 3 minus 1. Good?
You simplify that to 2?
Yeah. So the answer would be 3x squared. Good? Now, which is easy? Finding the difference quotient, then taking the limit, then finding the derivative, or that? Obviously this. So if you look at the rule that I wrote earlier, see, as long as you have a bunch of functions that are simply in product or difference, I could apply the derivative to each of them. Yes? So let me just call that to be f of x. G of x, and that's just a constant c. Yes? Now what is the just make a direct comparison between that and that. What is A? 4. What is B? 3. And the constant is simply 2. Do we agree? Okay. What does the rule state? I keep the constant as is, and I take the derivative of the function. I keep the constant as is, and I take the derivative of the function. I keep the constant as is, and I take its derivative. Yes? Now the exam is multiple choice, so I really don't care how you do this. You don't have to write it out, but understand the process behind it, because some of you might change your mind and go for calculus. So at that point you will need it. Now can I erase this? Did you have a question? What is the derivative of x cubed? We already know that. 3x squared. 3 comes to the front, reduce the power by 1. What is the derivative of x squared? 2 comes to the front, reduce the power by 1. What is 2 minus 1? 1. What is the derivative of a constant? 0. Which gives us 12x squared plus 6x. Always simplify. It is important to write it in a simplified form, because when you do the homework on the exam, what you would see is the simplified form. Back to algebra. Could I write this in a different way? How do we simplify?
You can take out a 2x or 6x.
We pull out the common term, and the common term between these two terms is 6x. So if 6x comes out of 12x squared, what do you leave behind? 2x. If 6x is pulled out of 6x, what do you leave behind? 1. And that would be the final answer. Is that making sense? It is all under finding the derivative, so let me not write it each and every time. Can someone tell me the answer? What is throwing you off? Huh?
I was gonna say, I think I have the answer.
What is the answer?
Is it 2x plus 6?
Is it?
Is that right?
That is correct. But a word of caution. I will put this as a remark. The rule B is what we call the power rule. Okay, that's just a remark. We will address this later on. As long as this just has x, you can find the derivative. The answer he gave me is actually correct. But if you have something else in here, such as x squared plus 3, what we did will not work. What's your name? Matt. What Matt did and the way he gave me the answer is not going to work. So, if you don't know what we will talk about later, it is called chain rule. The step here is to FOIL first. What would we get if we FOIL? Yes? You should be on your way to become expert. In other words, you don't really have to write each of those things, right? Just by looking at it, you should be able to tell me the derivative. What is the derivative of x squared by itself? 2x. 2 comes to the front. Reduce the power of x. 2 minus x is 1. You don't have to specify that because the power is 1. What is the derivative of 6x? The power is 1. 1 comes to the front. And you have x raised 1 minus 1, which is x raised 0. What is x raised 0? Any number raised to the power of 0. 1. So that would simply be 1. What is the derivative of that constant? 0. What do we have in common between the two numbers? Now do you see how power rule could have worked here? Yes? Bring 2 to the front, it's right here. Reduce the power by 1, you get 1 there. Yes? So it is perfectly fine to use power rule here, but you've got to be extremely cautious when we do something like this. Good? Now, what I just want you to guess. What would you do? I don't expect the correct answer. All I need is your thought process. So I can correct your thought process if you're wrong. Even I can't hear you.
I can't say, I don't know what the name is. You can see x times 4, and then 2x, and then 0.
Very good. Hold that thought. What's your name?
Okay.
Ophelia. Ophelia tells me that gotta write it as x raised to the 4th, then 2x cubed, then take the derivative. Any other types of thought? What would you do? Same thing? Okay. Does anyone, what's your name? Joseph? Justin, okay. Justin, Ophelia, both of them say, well, you have to write it as x raised 4 plus 2x cubed, then take the derivative. I am going to say, take the derivative of x cubed, which is 3x squared, take the derivative of x, I get 1. Did someone think of this? Write this on the side. Did this cross your mind? If you did this, or if this crossed your mind, you have to correct that thinking process. That's incorrect. The reason being, the rule that I wrote in part C, I said that is going to apply only if you have functions in sums or differences. Yes? Is that function and that function in a sum, or is it in a product? It's in a product, so you cannot do it directly. Again, later on there is a rule called product rule, which will make the process easier. So the first thing that you have to do is to distribute and rewrite that function. X cubed multiplied by x is x raised 4. 2 multiplied by x cubed is 2x cubed. Do we have the functions in a sum now? We moved from a product to a sum. Now I can take the derivative of the individual terms. What happens to that 4? That 4 is going to come to the front, x. Reduce the power by 1. 4 minus 1 is 3. I have a 2 in the front. What happens to that 3? It has to reduce the power of 3 by 1. What is 3 minus 1? 2. What is the next step?
Take out common factor. Take out common
Factor, right? We should always try to simplify whenever possible. Is there a common factor? I have a 2 and 2 there. There is another common factor, and what is that common factor?
x.
Just x?
X squared, yeah.
X squared. So if I pull out 2x squared from 4x cubed, I would have 2x. If I pull out 6x squared, 2x squared from 6x squared, I would have 3. How can you verify your simplification? How would you know that you did this properly?
Distribute.
Just distribute it back and you should get that. Yes? Okay. That is a good place to stop.